You're watching InTechnology. This episode is one in a series with innovative companies who are part of the Intel Capital portfolio. In these conversations, we'll explore the key areas of technology Intel Capital invests in to shape the future of compute.
Hi, I'm Camille Morehart. This episode is part of the InTechnology Intel Capital series, and today I will be co-hosting a conversation with Nick Washburn, who's a senior managing director at Intel Capital. Nick is a voting member of Intel Capital's investment committee and co-manages the cloud investment domain. That focus includes early-stage investments in cloud-native infrastructure, developer tools, AI, ML, and data platforms. He is also a director on the board of the National Venture Capital Association and is a member of the Kauffman Fellows. Welcome to the podcast, Nick. Who have you brought to the conversation today?
Thanks for having me, Camille. I've brought a good friend, close partner to us here at Intel Capital, where I've had the privilege of working with for a number of years, Kurt Mackey, who is the co-founder and CEO of Flyio. Interestingly, Kurt is based in New Orleans by way of Chicago. He was in Chicago when we first invested. Is now in New Orleans. And of one person I know in New Orleans, which is always exciting. I will turn it over to you, Kurt, and why don't you start off with what is Fly.io?
Sure. By the way, it's always good to know one person in New Orleans just as an excuse to come to this particular. It's like knowing a person with a boat. Fly.io is a developer-focused public cloud. And what the general theory of this is that in 10 years, the next version of AWS or GCP, the kind of big public clouds, is going to be something that starts with developers. It's going to be like hyper-focused on devs for a lot of reasons I'm sure we'll get into, but primarily because it makes sense for devs to be able to shift their own work faster and automate away a lot of the kind of the cruft that enterprises accumulate over time. I think the interesting thing about us is we started not quite as this. We started as a way to run apps close to users, as an edge compute platform. And over time, as we worked with customers, we just discovered that we were actually building a public cloud. Obviously, compute should run close to users. It's not like a novel feature. It's a baseline requirement of whatever the next public cloud has to be.
So what does it mean to be oriented towards developers?
There's probably two ways to tackle that question. So I think the simplest is there's a class of developers, and I was one of these, what I call impatient, pragmatic developers who just want to ship things and effectively make money off of them. And they don't necessarily have the patience for all of the ceremony that goes into the infrastructure and the bureaucracy that's sprung up around some of these things. The people I love to talk to most about are PHP developers. The whole world is talking about like VCs putting a ton of money into the JavaScript ecosystem, all these frameworks and things, and PHP developers are just like off making money somewhere. They're just not interested in kind of the hype necessarily. The tool is a way to enable their kind of apps and businesses, if that makes sense. And so I think that a developer-focused public cloud is actually perfect for the PHP devs. Not the most glamorous thing for, I don't know, the JavaScript thought leaders necessarily, because it's boring in a lot of different ways. But what it reduces is devs being able to incrementally ship impactful work quickly with a minimum of ceremony. They don't have to go ask permission for certain things. They don't need to go talk to another team to get the most bog standard of applications up and running. And they don't need to go talk to people to evolve from our first launch simple thing to a very complicated, scalable app down the road. It's just taking away a lot of times that you have to have conversations effectively.
When the public clouds was born, there was a couple shifts that happened. One was obviously migrating CapEx cost for a company to operating costs, meaning I don't have to run my own data centers. But there was also a simplicity story at the origins of the cloud as well. You don't need to think about a lot of things. You can just ship an application on some primitives of compute, storage, and networking and gets up and running. Now, since that time, things have obviously changed to where we are now, where it's incredibly complicated to use a cloud environment. What was the driver of why did it start simple? Why is it complex now? And then why is Fly back focused to start on simplicity, even though certainly things can scale?
Data centers, they're like a known quantity. We know how to build and operate data centers as a company. And if your company happened to come across a person who knew how to build and operate a data center, they would have not necessarily seen the benefit of the cloud. What happened, I think, is AWS made it to where the companies that were really bad at operating data centers just didn't need to worry about it. And what it did is it just replaced tooling, or replaced kind of expertise in a team you'd hire locally with tooling that worked consistently, that did what the vast majority of enterprises needed, that let them kind of get the things that they'd have to go procure from Dell and Intel over some weird procurement cycle that they all then had to manage. And so it just put a lot of that behind APIs. And I think it's the trick here is APIs instead of people. And I think that's the whole story of the cloud. But they also grew up in this world where they were trying to replace a local data center in Chicago or someone buying colo in Atlanta with a cloud. And so what they did is they ended up building these clouds in these cities, and you'd end up moving next door, basically. Like you'd end up going off of your data center that you leased from Equinix or Digital Realty Trust, and like literally move across the road to whatever it was always running within. And so what they did was they got rid of the people element that used to exist. Like I'm old enough to build this company because I have racked and stacked servers. But if you go talk to, 99 out of 100 startup founders have never even seen a physical server in their life at this point. And so that's kind of the impact Amazon had on the world.
I think the interesting thing, Curtis, is you're still racking and stacking servers because Flyio runs its own method.
It's actually a superpower for us because we can build data centers and networks, and not many people can do this. So we can actually tackle this from first principles in ways that are fun.
Now, coming at it from an on-ramp to shipping apps quickly comes being opinionated somewhat and having an abstraction that is high enough to enable someone to create a Docker image used from the CLI and it geographically runs. What are the trade-offs of that?
Most developers can run Flyio and get their app working on the cloud. They don't necessarily understand enough of what's happening to make good decisions about how to build their application all the time. One of the things we've been wrestling with recently is like disks fail. If you store data on a disk, with enough customers, someone's losing their data every day. And this is true for us. This is true for AWS. Developers that aren't quite as experienced with infrastructure just don't intuitively understand this. And what happens with the abstractions we've given them is it makes it so easy to get set up on infrastructure that you may never have to learn these things until it becomes a problem down the road. Whereas if you were doing it on hard mode, if you were going and racking and stacking servers, you'd end up developing this expertise that I think goes into helping and building a good back-end application. I think that's probably the problem with any kind of technology that automates a lot of what used to be hard. It's just that it is a leak. There's always leaks in the abstraction. And even with automation, I think the people who use it best are the ones that most deeply understand what's happening under the covers. But again, we get back to the PHP devs, and that's not them, and they don't care. And so for the most part, I think that the trade-off is like finding the right, UX that matches what they expect to have happen. And so what we shouldn't be doing is giving PHP devs a single volume that can fail and lose their data. What we should be doing is giving PHP devs a way to launch your app that is the right kind of layout for their particular application. And fortunately, like almost every full stack app has similar requirements. They need to run app servers. They need a database that doesn't go away. They need some kind of way to send email. They need backups of their database. There's just a lot that's very standard across literally every project on the planet. And so I think it's what I'd call it is a tractable trade-off, but that's to me the big one is you can be very naive about what's happening under the covers and still make progress. And this is actually great right up until something goes wrong.
How do you think about the scaling needs? So when you balance the Fly platform, there's a very quick time to value for a Rails developer, a PHP developer, Elixir, pick your framework. They can get a full stack app running very quickly in a distributed way. But as that application gets hit harder, more scale, more intensive reads and writes, the magic of Heroku back in the day was for Rails and Postgres. I could get going very quickly, but it had that technical graduation problem, largely because of the abstraction layer. How have you thought about this when you kind of architected Fly?
I think the really interesting thing about watching apps scale is they tend to scale in complexity faster than they scale in absolute footprint, if that makes sense. Like applications you're building will get complicated long before you have a ton of traffic because you want to solve some new novel problem. And like integrating an LLM is like a great example of this. Since the beginning, we've actually thought really hard about the day one experience for devs, which is get an app up and running. And then the day 100 experience for devs, which is actually be able to deploy more complicated stuff on top of it. And we've defined our like kind of ideal customers at this point as people that appreciate the value of a PaaS day one, but want to go beyond that very quickly. Platform as a service, a PaaS. And so what we did is we started at the bottom, and some of this gets into how we think the next developer focus, or how we think the next public cloud is going to look. But we started at the bottom, and basically the hypothesis, if you give people powerful enough primitives to like launch compute where they need it, even all the way down to the granular, like run one process on very little RAM in this city until it dies and then run it somewhere else. It's actually pretty easy to build a platform as a service on top of it. What we ended up doing was our product is actually the lower level API for running a VM to get compute and storage and RAM where you need it, compute including GPUs at this point. But the actual onboarding self-service funnel is the orchestration bit that makes it easy to launch an application. And what we did is we built infrastructure that we managed to run the VM API. And then the client side, or the orchestration all happens client side. Like our CLI actually has all of the magic for orchestrating a pass for people. So like when you run fly launch, it does all this smart stuff in the client to detect that it's a JavaScript app or a Next app or a Ruby app. It configures the app in the way it needs. It goes to like our build servers and gets a Docker image built. And then it actually manages rolling this out onto compute across the world. And there's been two things. We've tried to simplify what we're actually running, because I think running complicated orchestration stuff that for some devs it's really hard to run. It's really brittle, and they tend to outgrow it very quickly. And then we've done a lot of work to make the first time experience open source and available to users. So we actually have users go look at our open source kind of orchestration bits, and they'll either build their own on top of it, or they'll customize ours, or even submit pull requests to our CLI at this point. And so the general theory here has always been, we want to make some happy path stuff very magical, but we expect people to eject from that and just use the lower level primitives. Which leads me to the other, I think one of the big philosophies of the world that makes this make sense to us is that I expect the next big public cloud to actually be a rebel alliance of maybe 50 companies. If you go look at AWS's portfolio of products, there's 50 good ones and 200 not awesome ones that are just there because it checks some box that some person needs. And so my guess is that the next public cloud is going to have a company focus on each of those top 50 problems, building exactly what a developer needs from that, building something that in our certain like case, we tend to pitch this as building something that allows a developer to ship new kinds of apps that they were not previously able to ship. And part of why we focus so hard on the compute primitive is we think our place in the world there is as the compute provider for devs. We expect that devs who run apps will use us for compute, use something like Supabase for Postgres, use something like Tigris for object storage. But we have our very narrow focus there. And a lot of the rest of the work we've done is just to support the funnel of people coming in.
What do those integrations look like? So if I want to have maintaining a delightful developer experience, naturally, that would include if my object storage provider is Tigris running on Fly itself and in the same network, so the consolidated effects very fast.
Upstash does Redis on our platform. Supabase does Postgres on our platform. Tigris does object storage on our platform. They all run co-located with the rest of our services. So you get sub 1 millisecond latency to run database queries. You actually get sub millisecond latency to talk to your object storage, which I think I could go into why that's interesting. That's hard to do even on AWS at this point. But yeah, there's a couple of places I think working closely with partners makes sense. And one of them is that the underlying infrastructure should behave the way kind of a monopoly public cloud would today, which means low latency between components for the most part. And the other one is the UX should actually make sense. And so for us, we love the day one Heroku experience. And so what we're doing is which is launch an app, obviously. But what we do is our launch process actually goes and gets you Supabase, and we'll actually go and get you Redis, and also actually go and get you object storage, and offer these things up to you the same way it would if you were on something like AWS doing this. And this has got a really close partnership with the extension providers.
How are you seeing, or are you seeing the increase in machine learning and AI make changes to how you offer data center?
That's been an interesting one because we started, again, like we were all about the latency and still are. Like to me, if you're running an app and it takes more than 40 milliseconds to get information back from the thing, like it's too slow because it's human perception is 700 milliseconds is instantaneous, and I am very impatient and want instantaneous everything. And so I think two things happened concurrently. One is edge computing became a thing people cared about. Our devs, our customers, like the 250,000 people on our platform, run their apps close to the users just by default because that's what we do when you deploy the thing. But that actually necessitates a different kind of infrastructure than GPU stuff. And we actually saw this a little bit What it went, I think, was CDN us GPU stuff. CDNs had very lightweight power requirements. They wanted to run in 200 cities. Devs on us have heavier compute requirements. They want full CPUs and a lot more RAM. And so Cloudflare's infrastructure is hard to shoehorn into that for them because they just don't have that kind of footprint. We have fewer regions that are a lot fatter. And then GPUs are like an order of magnitude worse. They just need so much power. And the cost of anything with a GPU is so high that the power costs about the same as the GPU itself does. If you spend $10K on a GPU, you're probably going to spend $10,000 in power on it over the next 3 years. And so what we actually found is as we ship GPUs, we're even collapsing it down. We'll have GPUs in 6 regions. And part of this is because, again, like putting it where the power is cheap is the right choice. But the other part of this is the models just take so long to do anything. If your compute is going to spend 32 seconds giving you a response, like you don't particularly care about that last 2 seconds anymore. It just becomes less of a pressing issue. Like an actual infrastructure perspective, we went out to edge and now collapsing back to like literally cities with hydropower is what it's going to end up with just because it's like we are all spending too much money on converting stuff into heat at this point. The other interesting thing about GPUs, I think, is it's changed how even devs attack building and shipping applications. I think that up until GPUs, up until like kind of generative AI stuff became obviously valuable to people building apps. I think we're to the point now where most devs who are aware of what like LLMs can do can imagine ways of integrating in their application. To me, it seems like almost like a generational change in the same way like a relational database enabled a whole new kind of apps. What we're going to have now is a relational database letting you build those apps, and then LLMs letting you build even more different kinds of apps. And it's like that level of power, I think. And one of the, I think, interesting things about the world we're in right now is the whole way you deploy and manage models is like, nobody knows. We haven't figured this out yet. And our bet on some of this is you deploy and manage your ML code the same way as the rest of your code. And that's actually turned out to be a pretty good pitch for the way we think about the world is we build for developers and we sell to developers, but we also sell to whoever the developer reports to. And basically being able to build and ship an ML-backed application with the same ease as a full stack application has been a pretty good pitch to the bosses of engineers at this point.
Are you envisioning enterprises basically adopting like LLMs or Gen AI, more customized, so it's essentially a smaller model versus trying to incorporate all the information of the internet? Are you seeing a smaller, more customized, more distributed kind of a model? Do you think that's the future there?
We're actually seeing some pretty clever stuff. And I have a lot of hot takes about where inference is going to happen in the future, just because of the constraints and power and expense of all of this. But we're seeing customers do pretty clever things where they have actually a really small model that works fine on CPU, and then they have a fatter model that's GPU based. And then what they'll do is they'll try the CPU model first to see if they're happy with the results for their users, and then flip over to the more expensive one, if necessary. If that makes sense. And so we're seeing, I think, a lot of what I call model optimization. And it's not necessarily small models. It might be like an onion of small to larger, fatter models. But it's definitely where a lot of it is going. And it's realistically, it's because NVIDIA has such pricing power over the market right now. If you look, and I would like to buy a gaming graphics card for $1,500 and run my ML on it and sell that to people. But NVIDIA, no, you got to spend $20K on something that's 12% better instead. And so I think between the power and the expense of actual electricity and the pricing power of NVIDIA, we've seen a lot of pressure on developers to reason about their infrastructure in a way that they know can be efficient down the road. And I actually think the next thing that's going to happen is we're going to see a lot of like device local inference. So what you're going to see is people building in models that they can actually ship to the client. They can run on a really fast local, probably underloaded CPUs with power that like I'm not paying for first. And then they're going to do something like we're seeing with the users on small CPU models and then fall back to these big fat models over time. I think we're going to see those 3 layers of I'd tell them model intensity, maybe. It's like size, but there's more to it than that.
So hybrid, all over the map, pretty much anything, depending on what you can get away with. Really tailoring, I think you're saying really tailoring the compute to the application or the use case. And that can depend on, cost of energy, cost of hardware, latency requirements, all kinds of things. Yeah.
I think for this particular case, it's probably the cost of energy that's the biggest driver of this. If I'm an app developer and I want to have a good, solid business, I don't want to be paying for electricity for my people's ML stuff. And so I'm happy to just kill their battery life on their phone in exchange for not paying for electricity. So there's a really strong incentive to stay out of GPUs right now.
I wonder if we could pivot just a little bit and talk about security and or privacy. So however you want to tackle that, whether it's like your recommendation to app developers for what they should be thinking about right now, or whether it's what you think public clouds should be thinking about from a cybersecurity perspective.
One of our founders is a big security person, notable Thomas Stachek. And it's funny because he wrote the security landing page for us. And this is the cloud you would build if you just let security nerds make all the decisions, which is actually relatively accurate. And so the first thing we did is we are fundamentally architected in a way that is it can be very secure depending on how you deploy your apps. And so we've made a lot of choices that actually limit the UX in some ways. We've made a lot of choices about how we store sensitive kind of database secrets or sensitive credentials for things on your behalf, to how we do virtualization, how much we isolate people's processes, that I think gives us actually a surprisingly good security posture for a bottoms-up developer startup. I think typically when people build stuff for devs, they not necessarily ignore, or they may not be aware of what really good security looks like under the covers because they're so focused on the UX and there's so much tension between UX and security. And it's cool to be in that spot. One of the fun ways this is manifested is we're finding all these customers who want to run ML, but either because of regulations or because of their own paranoia, they cannot allow their training sets to be reused. And what we're finding is because we have GPUs in such a secure environment, they actually trust our infrastructure for doing this. They trust that they can do ML stuff. They can ship their models on us and know that no other user is going to get access to it, which I think that's the biggest, scariest thing for devs right now.
So Nick, a question for you, is I think it's fairly rare people get to talk with certainly somebody from Intel Capital about what you think about in making an investment decision. So I'm just curious, what is top of mind for you, or what is something that we might not think of that you focus on?
Yeah, I can contextualize it in the origins of Fly. We tend to be pretty thesis driven as opposed to opportunistic. And I first read about Fly, I think it was a Hacker News post in early 2020 when Fly was starting to transition, I think, from very much run workloads close to end users to more of a public cloud. And it just resonated, one, because, there's a lot of developer love, but two, we shared a belief that what we call a modern distributed cloud stack was emerging, which had a couple of kind of core components to it. Delightful developer experience, meaning I don't need to go and see a menu of 700 services to stitch together and have a platform team to be able to ship an application. I could take something I know in the language I love, make no changes to it, and it magically runs in many different regions. And that was kind of what we read of what users were doing at that time. And the second thing was we did believe that you needed to run your own metal to be able to do this. Actually, there are PaaSes and versions of IaaS out there that are abstractions on infrastructure provided by other public clouds. But to really be able to offer low-level primitives, you need to have your own metal. And why do I think we need to have low-level primitives? To solve a technical graduation problem. And that's what Kurt was talking about, a day one experience, but a year or two, this is still running mission-critical workloads that it built into. We look at developer tooling, at infrastructure software. The aperture upon which you look at it is a little different because the companies will look the same. It's often very early revenue, a lot of usage, but whether it's a kind of core infrastructure that's being adopted by a DevOps team, that's a very enterprise sales kind of lens we're looking at. Versus when I look at something like Fly early on, it's almost like looking at a consumer investment. We're looking at usage, product love, how many applications the same users putting on the platform, what that journey is to the individual developer. And when we got to know Kurt and got to know Michael and Thomas and Jerome, the other kind of founders, and what the worldview was, it was very aligned with our worldview. And so we jumped on it. And it's been a privilege to work with them since and see the journeys and usage from when we first invested to where they are now, the amount of users and applications and databases on top of it's pretty amazing.
I want to add on to what Nick said real fast about the graduation problem and running on your own metal. And I think one thing that's easy to not notice is that the big clouds exist to eat software margins. They're heavily incentivized and very good at extracting all the margin they can from the dollar that your end user is spending. And this is, I think, part of the graduation problem is people on Heroku, it got very expensive very fast because Heroku could not actually be like price competitive or even in the same ballpark as AWS for things. And we ended up doing the physical hardware, both because we had to kind of ship the features we thought we needed, but also because there's no way to build an enduring business that's threatening to AWS on top of AWS purely for economic reasons. And so it's been, everyone thought I was crazy when I said that in 2020. I think Nick might have been the first person like, yeah, that sounds right, like 9 months later. And then the later round investors were like, yeah, obviously that's true. Obviously that makes total sense. So we finally managed to convince people of that.
Very cool. Kurt Mackey, CEO and founder of Fly.io. Thank you so much for your time today. Very interesting conversation.
Thank you.
And Nick Washburn, Senior Managing Director of Intel Capital. Thank you for co-hosting with me. It was a lot of fun.
Of course, it's a pleasure. Thanks for having me.
Never miss an episode of InTechnology by following us here on YouTube or wherever you get your audio podcasts.
The views and opinions expressed are those of the guests and author and do not necessarily reflect the official policy or position of Intel Corporation.